Motion After Effect. Stare at the center of this moving image. When I tell you to look away, you'll see everything around you zooming and moving, creating a kind of breathing movement. This happens because your eyes try to adapt to this type of movement, and when you look at something stationary, they take a while to readapt. Amish room. Take a look at this man walking inside an Amish room. When he goes to the left side, he seems small, but when he goes to the right side, he seems like a giant. The two sides of the room have the same height, but the right side is much closer to the camera, making the person appear bigger. Flashed face distortion effect. When you stare at the center of this cross, the faces on the sides start to appear deformed and grotesque. This phenomenon was discovered by chance, and there's not yet enough research to understand why this happens. Stepping feet illusion. These two buses seem like they're moving step by step, but when the background black and white strips are removed, the effect is mostly caused by the contrast between the buses and the background stripes. Silencing effect. If you look at the center of this image, you can see the small balls change in color. But when the balls start rotating, they seem to keep the same color. This happens because it's harder to notice changes on moving objects. After image. Stare at this image. When I show you a white screen, you'll see a negative after image, which in this case will be cyan on magenta. This happens because the chemical activity in your retina continues even when the eyes are no longer experiencing the original stimulus. Color dove illusion. Stare at the four dots in the center of this image. This illusion uses the same mechanism as the after image illusion to create existing things like faces. You should be seeing a picture of Jesus right now. Impossible object. An impossible object is a two-dimensional figure that represents a three-dimensional object but cannot exist as a solid object. Examples include the Penrose stairs, the Penrose triangle, and the impossible cube. Hybrid image. In this image, you'll see Albert Einstein if you look from a short distance and Marilyn Monroe if you look from afar. This happens because the image combines the low spatial frequencies of one picture with the high spatial frequencies of another. Ponzo illusion. The upper line looks longer because we interpret the upper part as receding into the distance. This is caused by the same mechanism that makes us perceive 2D images as 3D ones. Poggendorf illusion. In this image, it seems like the blue line is the continuation of the black one, while it is actually the red one. This is caused by the properties of the obscuring pattern and the nature of its borders. Forced perspective. Forced perspective makes an object appear farther away, closer, larger, or smaller than it really is. Tourists posing with the Leaning Tower of Pisa use this technique. Barber pole illusion. The diagonal lines in a barber pole actually rotate horizontally and do not go up or down. The vertical movement is just an optical illusion. Zellner illusion. These lines do not appear perfectly parallel, but when the shorter lines are removed, the longer lines are indeed parallel. The angle of the shorter lines creates the impression that one end of the longer lines is nearer to the viewer than the other end. Calf wall illusion. These lines appear sloped, but they are actually parallel and straight. The effect is due to the white areas appearing larger than the black ones, and it disappears when the colors are changed. Wand illusion. The two red lines appear about inwards, but they are actually straight. The lines in the background create this distortion. Fraser spiral, also known as a false spiral. The overlapping black arcs are actually a series of concentric circles, not a spiral. Vertical horizontal illusion. The vertical line appears longer than the horizontal line, but they are both the same length. Crater illusion. Crater-like holes appear as mountains or domes. This happens because we are accustomed to seeing light from overhead. Kenosha triangle. This image gives the impression of a bright white triangle despite the absence of lines or color change across the edge. Some people perceive the illusory triangle as brighter and closer. Kinetic depth effect. A spinning dancer can be seen to spin in both directions due to a lack of visual cues for depth. With more visual cues, you can determine the direction of the spin. Rotating snakes effect. These stationary circles appear to move due to contrast and small involuntary eye movements. Turnus illusion, it seems like only one circle is moving, but with a small blank frame added, it seems like both are moving. This is linked to Gestalt psychology and is a type of apparent group motion. Beta movement. This is an example of apparent motion, like in the snake game, where you perceive movement instead of some random circles appearing and disappearing. Phi phenomenon, unlike beta movement, this involves no movement of the circles, just their disappearance, yet it still creates a perception of movement. Lilac chaser. Stare at the cross and you'll see a gap running around the circle. Then a green disc appears in place of the gap, and eventually you see only the green disc on the gray background. Gravity hill. This place makes a slight downhill slope seem like an uphill slope, like in the image where water seems to run uphill. Ebbinghaus illusion, the two orange circles are the same size, but the difference in surrounding circles makes the right one seem larger. Stroboscopic effect, you perceive the clock hand as moving from right to left, but covering it for small periods creates the illusion similar to the wagon wheel effect. Bezold effect, the red lines on the white background appear lighter and the ones on the black background appear darker. Ehrenstein illusion. The sides of a square placed inside concentric shapes appear curved, like a shuriken. Sander illusion, the diagonal line in the left parallelogram seems longer than the one in the smaller right parallelogram, but they are the same length. Muller-Lyer effect. The two lines are the same length, but the arrows at the ends create the illusion that they are different lengths. Hermann grid illusion, gray blobs appear at the white intersections, but only if you don't look directly at them. Rubens vase, is this a vase, or are they two faces looking at each other? This is an example of ambiguous two-dimensional forms and figure ground distinction. Contrast illusion. The contrast illusion occurs when a stimulus is perceived differently depending on the surrounding stimuli. For example, red dots on different backgrounds appear to be different shades. Mach bands, your eyes exaggerate the contrast between edges of slightly different shades of gray when they touch, triggering the edge detection system. Leaning tower illusion. The tower in the right photo does not lean more to the right. It's an exact duplicate of the left photo. Hollow face illusion. A concave mask of a face appears as a normal convex face, demonstrating the power of top-down knowledge for vision. Color constancy. You can recognize colors in this photo even though it is composed of only light and dark shades of red and white. This is due to color constancy, a feature of human color perception.